Hi everyone, in this video we will be determining if a subset of a vector space is linearly independent. So what is a subset? Subset is just a vector of space. Just for example, A, B, C, D, E, F. So these are the sets of vector in a subset where you get in the R of n dimensions. So now how are we going to determine if a subset of a vector space is linearly independent? So for any distinct S1 to Sn, where S1 is your vectors, we can write the linear relationship in this form. So where 0 will be my 0 vectors. So it depends. If you have a vector of 3 rows, 1 column and 3 rows, you will write in this form 0, 0, 0. So this is the 0 vector. And after that, based on this, we can construct an augmented matrix, which consists of the matrix of coefficients, which is basically the set of vectors in the subspace as here, and the matrix of constant, which is 0. So for example, in this case, we have two sets of matrix. So we can write in this form: A, B, C, D, E, F. And this 0 here, we can write it as 0, 0, 0. So this is my augmented matrix. And now we have already learned how to reduce the matrix to reduce row echelon form. So now by reducing to this form, we can find the values of C1 all the way to Cn. For in this case, it's C1 and C2 because we have two sets of vectors. So your number of sets of values of C will depend on the sets of vectors. So in this case, if you have two sets of vectors, therefore you have C1 and C2. So now if your C1 and all the way to Cn equals to 0, so in this case if you have C1 and C2 equals to 0 and C2 equals to 0, we can say that the linear relationship among those vectors is a trivial one, and we can say that the subset is linearly independent, which means that they are not dependent of one another. So now we have this example where we have these vectors. So we want to see whether they are linearly independent. So now let's write it off. Just write the linear relationship first. Step 1. C1, so this is my S1. This is my S2. So it's C1, S1, which is 0, 0, minus 1, plus C2, 1, 0, 4, equals to the 0 vector. So now you have 3 rows and 1 column. So it's 0, 0, 0. So now let's construct an augmented matrix based on this. So therefore, this is step 1. done. So now let's write it in our matrix form. So 0, 0, minus 1, 1, 0, 4 will give me the constant of matrix is 0, 0, 0. So step 2 is done. Let's do step 3. Reduce it to row, make it to reduce row echelon form. So now from here, now we can bring we can swap. Now this is row 1, row 2, row 3. So now we can swap row 1 with row 3 first. So it's minus 1, 4, 0, 0, 0, 0, 0, 1, 0. So now what is our condition? You want to make it to a reduced echelon form first. So you notice that now this is our new row 1, our new row 2, our new row 3. So you notice that row 2 is the row of zeros. So as row echelon form, this row has to be the bottom row. So we swap row 3 with row 2. Hence, you get again minus 1, 4, 0, 0, 1, 0. So now the 0 rows will go under here. So now the final step is to make our leading entries into 1. As you can see, for the first row, the leading entry is minus 1. So how to make it to 1? We add minus 1 times of row 1. So our new row 1 will therefore be minus 1 times minus 1 is 1. Minus 1 times 4 equals to minus 4. Minus 1 times 0 equals to 0. Second row will still remain because its leading entry is still 1 and 0. 0, 0, and 0. So now it's already in row echelon form. Now we can make it to reduce row echelon form by pivoting upwards, which means now we start from column 3 where we can eliminate the entry above 1, which is this. Sorry about that. So we want to eliminate this entry here. So now from here we add 4 times of row 2 to row 1. So to eliminate this, therefore, let's start from the bottom first. 0, 0, 0. So row 2 will still be constant. 0, 1, 0. So now for the matrix of coefficients, 4 times 1 equals to 4. 4 minus 4 equals to 0. 4 times 0 equals to 0. 0 plus 1 equals to 1. 4 times 0 equals to 0. 0 plus 0 equals to 0. So now we have got in this form. So from here, we can see that the last equation is redundant. It is consistent and yet redundant, so we can ignore this. So now for this, we can see that from here, C2 equals to 0, C1 equals to 0. So here, our step 3 is in reduced echelon, row echelon form, because 1 is the only entry in this column, and same for this. So step 3 here, step 3 done. So for here, we found the values of C1 and C2. So step 4 done. Step 4 done. We found this. Therefore, we can say that it is linearly independent. And hence, the subset containing this is linearly independent. So, tada, we have done it. And thanks for watching this video. If you have any questions, please feel free to drop me a comment and I'll reply to comment as soon as possible. Have a nice day.